very much indeed for listening to this tutorial video in which I'm going to show you how to calculate odds ratio and relative risk as well as the interpretation. First in theory, and second of all we'll go into SPSS in order to show you how to use this tool in order to practically implement the calculation of odds ratio as well as interpretation. So let us start first of all with theoretical foundation of odds ratio and relative risk. By definition, we can say that the odds ratio is a statistical measure mostly used in epidemiology in order to express the degree of dependence between two qualitative variables. So in odds ratio analysis, we have two qualitative variables that we are going to search for the link between the two. Odds ratio can be also defined as a ratio of odds of events that happen in the individual group A, for example the disease, with the same event happening in the group or in the individual group B. So what's odd? Odd is a ratio of a probability of an event and a contrary of the event. So if the probability that the event happened in the group B, in the group A is P, and Q is probability in a group B, odd ratio is calculated as follows: odd of the probability that the event happened in the group A and odd of the probability of the event in the group B. How to compute really odd ratio? We have, for example, a disease, some person that are affected by the disease. So there are A person that are affected by the disease and exposed. B person didn't have a disease but are exposed to the disease. So we have two groups, the group of exposed and the group of unexposed to the disease. We have a group of affected, that's called cases, and we have a group of control, that's the person that didn't have a disease. So if you have this contingency table showing the relationship between the occurrence of the disease and our factor, that is a group of exposed or unexposed to disease. A group of exposed or unexposed to the disease can be a group of male and female person or any other variable that can be used in order to express the link or the dependence between two variables. And so the odds ratio is calculated as follows. We have E over C divided by B over D. So you can also have this relationship A times D divided by B times C. So in this case, the probability that disease occur in the group of exposed is A divided by A plus B. The probability that the disease occur in the group C, in the group B, or the group of unexposed person is C. The number of person exposed among diseased person divided by C plus D. That's the total number of exposed person. So the odds ratio is calculated as odds of probability to belong to different group. That is same relationship that we show you very earlier in this tutorial video when we take this P and Q variable of our probability to belong to the exposed and unexposed group. So what's the interpretation of odds ratio? We have the interpretation. When the odds ratio is close to 1, the event is independent in the group. That means that if our main variable is a disease, in the previous table that we show you earlier, we can say that if the odds ratio is close to 1, that maybe disease and gender are independent. Gender didn't significantly influence the occurrence of the disease if we have the odds ratio close to 1. But if you have a contrary odds ratio that is superior to 1, we can say that the event is most frequent in the group A than in group B. That means that belonging to the group E is at risk. When one tend to belong to the group A, increase your probability to have a disease if you stay in epidemiology situation. And the other situation is when we have the odds ratio that is higher than 1. So that means that the event is hugely most frequent in group A than in group B. So we have already a case where the odds ratio is inferior to 1. We can say that the event is less frequent in group E than B. What that means that when you are in group B, you tend not to develop a disease. And the last case, in the case when odds ratio is close to 0. So that means that the event is hugely less frequent in group A than in group B. So let's take an example in order to illustrate the practice how and use odds ratio in order to interpret a risk factor. We have a sample of 200 individuals in which we have 100 men and 100 women that have drunk wine in ongoing week. So we define our main variable, that is alcoholism. Like you are alcoholic if you have drunk in this week while you have drunk in the previous week. Every person that we have selected have drunk in the ongoing week, and person that didn't drink in the previous week are supposed to be non-alcoholic. That is why how we have defined our variable alcoholism. So in our sample, we have 19 men that have also drank the last week that are alcoholic, and only 10 of the 100 men have not drunk on the previous week. And let's look at women population. If you look at women population, we can see that 20 women in our sample have drunk in the previous week among 100 men that have drunk of the current week. So we can calculate the odd ratio, and we found that odd ratio is 36. That means that being men is a risk factor of developing alcoholic factor. That also means that in the group of men, alcoholic is 36 times more higher than in the women population. Let us go in SPSS to show you how odd ratio and probability risk are calculated. So you just need to go on Analyze and go on Descriptive Statistics and click on Cross Table. Go on Cross Table and you select a variable of control. So for example, as this is the database on satisfaction survey that has been made on the client of a shop, we now search for element of buying or not the product. So there are so many questions that has been asked to those who accept this survey, so that they buy or not the product. So for example, we are going to search for determinant of buying or not a product. So our treatment group is those who buy a product, and our control group those are the person who doesn't buy product. So we select the variable that buy and use this arrow to put it in the column section, result to the cross table in SPSS. So second of all, select the determinant, so the variable according to which you are going to calculate risk statistic like the odd ratio or relative risk. So variable is gender. So I go to analyze the risk whether or not gender is a determinant of buying or not a product. So while I have selected all my two variables, I will go on statistic and select risk, and then click on continue and OK. I have a cross table here which represent the cross table of buy and gender. Have in the estimate here odd ratio for gender. So we have odd ratio male by female is 1.176. If you consider that this odd ratio is significant, mean that men are more likely to buy than women. The interpretation of our odd ratio of 1.176 here is that men are 1.176 times more likely to buy product than women. So we have the 95% confidence interval here. So lower value is 0.81 and the upper value is 1.76. We have here for cohort buy equal yes. So this is a relative risk according to the yes to those who buy the product. So the relative risk is 1.05, and here is a confidence interval. Here are the two main statistics. So here the relative risk is close to 1, which means that gender made no difference at all in the buying process. So we can say the same thing for the odd ratio, because maybe odd ratio is seemingly more than 1, but it's not really significant because confidence interval contain 1. So there are part of confidence interval that are less than 1 and other part are more than 1. So we cannot conclude that sex significantly determines a decision buy or not a product. So that's it for this tutorial on how to calculate odd ratio and relative risk using SPSS.